SQL Webquest Presentation, 18th of November 2016, for the group shown. My name is Roisin Parr and I'm providing the voiceover for this presentation. First topic, SQL triggers. Here we have an overview of triggers. The web page was chosen as it provided an overview of triggers, their types, states, data access handling, guidelines, and examples of when to use. It functions both as a prerequisite to the specifics of their use and a general reminder. A trigger is a named program unit stored in the database and fires or triggers in response to a specific event. It may be defined on a table, view, schema, or database. System triggers are defined on the schema or the database. A simple trigger can fire before or after a trigger statement executes, or they can fire before or after each row triggering statement affects. Compound triggers can fire at multiple timing points. They make it easier to program an approach where you want the actions you implement for the various timing points to share common data. Trigger types split into the following: DDL triggers, including create, alter, or drop; DML triggers, delete, insert, or update; and other database operations, such as server error, logon, startup. An enable trigger executes its trigger body if the triggering statement is entered and the trigger restriction, if any, evaluates to true. A disable trigger does not execute its trigger body even if the triggering statement is entered and the triggering restriction evaluates to true. Data access for triggers. In all cases, the SQL statements running within triggers follows the common rules used for standalone SQL statements. If triggers fire while the tables they are referencing are undergoing changes, queries see the current read consistent view of the table, including data changed by the undergoing transaction. Updates wait for data logs to be released. Guidelines. Triggers supplement the standard capabilities of your database to provide a highly customized database management system. Use triggers to guarantee that when a specific operation is performed, related actions are performed. The size of a trigger cannot exceed 32 kilobytes. And don't create recursive triggers, and don't define triggers that duplicate database features. Examples of when to use triggers: defining and preventing invalid transactions, automatically generating derived column values, and gathering statistics on table access. You can enforce complex business rules and use it to enforce security authorizations. Using triggers in Oracle. The web page provides Oracle's reference to trigger statements. We will be using Oracle Database later in this course. It also provides various configurations and some examples of using triggers. A trigger is automatically fired under specific conditions: before the SQL statement is executed, after the SQL statement is executed, and instead of. Fire trigger instead of executing trigger event. Note that before and after are not available on views while instead of is. The different timing outlined here can be actually overridden using follows. Delete, whenever database deletes a row or an element. Insert, whenever database adds a row or to a table or adds an element. And update, whenever database changes a value in one or of the columns specified. In addition, triggers can also be fired on DDL events, like alter, analyze, create, drop, or truncate. The first example shown here is calling a procedure in a trigger body. You could create the salary check by calling the procedure instead of providing the trigger body in a PL SQL block. Assume you have defined a procedure check cell in a HR schema, which verifies that an employee's salary is in an appropriate range. You could create the trigger salary as shown. The second example is of a trigger. The example shows the partial before row trigger. The PL SQL block might specify, for example, that an employee's salary must fall within an established salary range for the employee's job. The database fires this trigger whenever one of the following statements is issued: an insert statement that adds rows to the employees table, an update statement that changes values of the salary or job ID columns of the employees table. Salary check is a before row trigger, so the database fires it as changing each row that is updated by the update statement or before adding each row that is inserted by the insert statement. Salary check has a trigger condition that prevents it from checking the salary of the administrative vice president. We now move on to SQL as a programming language. Here is an overview. This link provides the Oracle PL SQL User's Guide and Reference. The User's Guide and Reference is very extensive. The first chapter was chosen as it provided an overview of the program, which is split into 3 parts: understanding the main features of PL SQL, its architecture, and its advantages. The sample program demonstrates the features of PL SQL. It provides an order for a tennis racket. A variable is declared to hold the quantity of tennis rackets. The quantity is received from a table and stored to the variable. Depending on the value of the variable, a table is updated or changed. PL SQL allows to use SQL within a procedural language very efficiently. The graphic outlines the PL SQL architecture. The engine can either reside on the Oracle database server or within Oracle tools. Either way, the general architecture is the same as outlined in the picture. PL SQL is a high-performance transaction processing language. Hence, it contains support for SQL, including its advantages, while also allowing to create high-performance programs. We'll now look at scope and visibility and data structures in relation to PL SQL. Nested subprograms defined in the declare section can be called from either of the other sections, but only from within the same block, where they defined or within contain blocks contained in that block. An ambiguous reference can arise because objects of subprograms contained in different blocks can have the same names, even if they have overlapping scopes. Qualification is a method used to override this. It is similar to the system of qualification used for database objects. To qualify an object's name, precede it with the name of the subprogram where it is declared, followed by a dot. PL SQL tables. These are somewhat similar to database tables, except that they always consist of 2 columns, a column for values and a primary key. This also makes them similar to one-dimensional arrays, with the primary key functioning as the array index. Like SQL tables, PL SQL tables have no fixed allocation of rows, but grow dynamically. One of their main uses is to enable you to pass entire columns of values as parameters to subprograms. With a set of such parameters, you can pass an entire table. Records. As in many languages, these are data structures that contain one or more fields. Each record of a given type contains the same group of fields with different values. Each field has a data type, which can be record. In other words, you can nest records, creating data structures of arbitrary complexity. As with tables, you declare records by first declaring a subtype. Cursors are different from the other two, in that you declare variables and constants to be of type table or record, just as you would any other data type. Cursors, on the other hand, have their own syntax and their own operations. PL SQL procedures. We chose this link because it gives us an extensive introduction to the use of procedures in SQL. A procedure has 3 components: the declarative, the executable, and exception handling. The declarative is used to declare all entities used by the procedure, including the declaration of types, cursors, constants, variables, exceptions, and nested subprograms, but it is purely optional. As is exception handling, it contains the code that handles runtime errors. The executable is the main body of code containing statements that perform the designated action. The first example is what is called a standalone procedure. It can be called using the execute keyword or from another PL SQL block. Procedure name specifies the name of the procedure, or replace option allows modifying an existing procedure. The optional parameter list contains name, mode, and types of parameters. In represents the value will be passed from outside, and out represents the parameter which will be used to return a value outside of the procedure. Procedure body contains the executable part. The as keyword is used instead of in this keyword for creating a standalone procedure. The second example is a procedure that takes some parameters and returns the result. The declarative section at the beginning lists all of the variables used, followed by the executable. The third parameter is used to hold the result. The inputs and outputs are identified by the in and out keywords respectively. in parameters and are read-only, but out parameters can be both read from and written to. A third type parameter, in-out, can be used as both an input to a procedure and a resulting output. A standalone procedure is deleted with a drop procedure statement. Actual parameters could be passed in three ways: positional notation, named notation, and mixed notation. This concludes the presentation.